ever wondered what happens when you press your computer power button? If you have never wondered about that, then this video is absolutely not for you. But if you are curious to find out, then in this video I will show you the exact steps from pressing the power button to the login screen. What happens behind the scene. This video is specifically for Linux systems and modern computers, but the process is almost the same for old computers and for other operating systems as well, like Windows. I just chose Linux specifically because, I mean, come on, we all know that the penguin looks super adorable, and because it is also part of the Linux concept series that I'm doing on YouTube, so I chose Linux. As I always say, an image is better than 1,000 words, and a cool animation is better than 1,000 images, because I mean, yeah, obviously animation is just multiple images quickly moving one after another. Anyway, now imagine you have a laptop and you pressed the power button. First of all, electricity starts flowing in the motherboard and powers on CPU. CPU starts running, it kicks in. The CPU then starts executing commands from a very small program called UEFI or UEFI or UEFI or whatever. And this small program is located in a small chip attached to the motherboard. And the CPU knows exactly where to find it, because this is something that is hard coded into the CPU. So the CPU starts running commands from the UEFI, and the UEFI program checks if all the hardware is working properly. If something is wrong, probably you will hear a beeping sound like. The process of checking if a hardware is okay or not is called post, a power on self-test. We don't care about naming, of course, in this channel, but it's good to throw it in there so people do not give me a lecture down below in the comments. Anyway, UEFI then searches the connected storage devices, for example, your USB drive, the hard disk, memory card, every storage device. UEFI goes and searches in these devices looking for a specific file system called EFI. By the way, a file system is a type of file structure, let's say, that is used in storage devices. For example, when you format your USB drive, it asks you what kind of structure, file system, you want to be used inside this USB drive. And from the user perspective, from our perspective, they all look similar, they are the same, but in principle they are different under the hood, but we don't care about that. Anyway, the UEFI looks in all storage devices and it searches for an EFI directory structure, file system, whatever. Would you be my EFI? No. Would you be my EFI? No. Would you be my EFI? Finally, if a device answers yes, then it goes into that file system looking for a small program called GRUB. UEFI loads this GRUB program into memory and tells CPU to start running it. And this GRUB program has really nothing to do with the operating system, but its main responsibility is to search for operating systems in EFI file systems, then use that operating system. So it's mainly a main menu. If you're into gaming, it's the main menu, the menu that allows you to choose which game you want to play. In computer science, we call these kind of applications the boot managers or bootloaders. So keep that in mind. I'll just call it operating system picker because it picks an operating system, obviously. If you have multiple kernels, the GRUB shows a simple graphical user interface, a simple menu to choose which kernel you want to load, which kernel you want to use. After some countdown, if you do not choose any operating system, it will load the default one. And of course, the GRUB configuration can be found in the boot grub.config file. And you can configure that. You can even configure it on your system. However, I do not really advise you to do that, because if you mess it up, GRUB will not be finding the correct operating system, the correct kernel, thus nothing will be booting up. If GRUB fails, you fail really early and nothing will boot up. So after GRUB finds the kernel, it loads it into memory. However, it does not load the kernel alone. It also loads a bunch of files and folders to the RAM, to the memory. And these files are all collapsed together into a single entity, and that entity, that huge file, is called initramfs. Now, this entity is not really huge at all. It's quite simple, quite minimal. It has really the initial drivers that allows the kernel to talk to the storage devices. For example, storage devices like your USB drive, the hard disk, the memory card, etc. And that's almost it. It has some other files and of course, programs, but these are quite minimal. Just keep in mind that, or just think of initramfs as a temporary root folder that is loaded into the RAM, and the kernel can just use that root folder with the applications inside of it. Now, in the RAM, we have the kernel and initramfs, the kernel, which is an application, and the initramfs, which is a folder. The GRUB tells the CPU to start running the kernel and says goodbye, I'm out of here. So then the kernel starts running and it loads the drivers from the initramfs, which is the folder that we just loaded, the GRUB just loaded to the RAM as well. These drivers allows the kernel to communicate with the hardware, as we said. If you want to know more about devices and drivers, please check this video, it's only 5 minutes. Now the kernel starts looking for the storage device that contains the root file system. Now this is important because this root file system is literally the main concept of operating system. It contains all the programs, all the applications that defines what an operating system is. Think of it as a directory. And then the kernel just takes this directory, mount it, and after we have this directory loaded, we will have a real root folder. So we do not need actually the initramfs because these contain also applications and programs, but they're quite minimal. So the kernel will just say, okay, goodbye initramfs. Why do I need to use you anymore? While we have this great entire operating system, this entire root folder, root file system full with applications and programs that are quite useful. By the way, in Windows or Windows terminology, the root file system is always called the C drive. You can change that, I think, when you install Windows. Also, I want you to know that you can also tell the kernel where to find the root file system, and you can do that by changing the GRUB configuration, because as you know, the GRUB starts the kernel, so it can also tell the kernel where to find the root file system, in which storage device. Finally, after the kernel mounts the root file system, gets rid of the initramfs, it starts an application called systemd. Now this is important because this application, previously known as init process, is responsible for starting other applications that are used by the operating system. For example, the graphical user interface, the login screen and login manager, authentication manager, etc. Once the systemd starts all applications, finally you are prompted to log in with the user and password. And this was it for today. That was fun. Now, I want to thank all of you for supporting, watching and learning. I hope that this video was helpful and provided a very good insight into the Linux modern boot process. And as always, if you learned something new, please share the video with your friends and family. Write your idea in the comments section below. There is a huge list of ideas that I want to cover in the future, almost all of them: virtual networks, printer and scanners, APIs, device mappers, a bit of wine as well, and how to become a farmer. Beautiful ideas, and looking to implement every single one of them. Farming can wait, of course. Anyway, I hope you enjoyed it, and till the next time, peace.